Start recording. Start your chapter. Okay. So let us start this whole scenario once again, which we started day before yesterday. Word on. And we completed so many ideas about spring forces, correct? Today, once again, we'll go through that spring, and one last topic I'll be dealing spring pseudo forces and we'll be dealing with also pseudo forces and equilibrium, and then we'll go back to friction directly. Is that clear or not clear? As we are following phase 4 planar fully, we'll stick to that planar, and whenever something will be required, we'll go through that. Is that clear or not clear? Okay. Everyone, is this clear? Now, so yesterday in cutting of springs, we took two spring scenario. Similarly, I'll be taking today one or two more cases. Let's take one more example. Okay. Guys, are you here? सो तो नहीं गए हो ना? बलकवास
कौन सो रहा है?
नहीं सो रहे हो ना? अरे यार केक कर रहे थे तुम लोग, हाँ? सो रहे थे कि so let's suppose the first block is connected with the string and the second block is connected with spring. Okay. Masses of the block are given m, spring constant is k. Again, same kind they are asking you. Find the देखो क्या अरे आज तिवारी आएगा. अरे यार अभी रुक जाओ, तुम लोगों को जगाने वाला असली शेर आ रहा है. फाइंड द acceleration of blocks okay, and find the acceleration of block if in first case string is cutted and in second case spring is cutted. Be fast. श्रुति जग गई? तिवारी को जोश चाहिए. तिवारी बोल रहा है मैं भी आऊंगा भैया. हाँ मैं भेज रहा हूँ उसको लेके. Answer fast. आदन जल्दी बनाओ. तुम लोगों ने टेस्ट दिया था वो ऐप पे मैंने जो बोला था?
जब ऊपर वाला कट रहा है तो 2G से ऊपर वाला, नीचे वाला तो 0. स्प्रिंग कटेगा तो ऊपर 0, नीचे वाला 0.
स्प्रिंग कटेगा तो ऊपर वाला
स्प्रिंग कटेगा तो ऊपर वाला 0 हो जाएगा.
ओके, एंड नीचे वाला
0.
जी. श्रुति सेम आंसर. श्रुति बेटा बता दो. जल्दी बना. स्ट्रिंग कटेगा तो क्या होगा? पहले स्टेप 1 देख ले. What was our step 1, guys? Write the spring force in equilibrium. Second force was write the spring force or tension force, whatever is there in equilibrium, okay? And whenever you cut a spring or thread, tension or spring force will both become zero. Is that clear? Draw a new FBD and then find the acceleration. This is the method, correct? Use like that. Okay. आंसर आ गया? Okay. So look over here. Case 1. We'll discuss case 1 first. When string is cutted. Okay. If I cut this string, so first of all, I have to draw the forces in equilibrium. This is mg. This is a spring force. This is also a spring force. Again, the weight how much? mg and tension T. So when string is cutted, what will become zero? Tension immediately becomes how much? Zero. Now, if I take the FBD of two blocks of mass m, okay. If I take the FBD of these two blocks of mass m and m, so upward block, net tension will become zero, so there is no force, but downward there is a spring force, and then there is a weight mg. While for this mg, this mass means this is my second block, this mass spring force is upward, and weight is how much? mg. Can you understand this? This is this one, and this is this one. You will get me or not? Clear? So if I write like this way, then here spring force is exactly, now in equilibrium, spring force is exactly equal to mg. So therefore, this one will have net acceleration downwards, and this one will be at rest because the spring force will not immediately become zero. Still in equilibrium. And this acceleration will be a, where the value of this acceleration will be fs plus mg divided by total mass moving, and that mass moving is Tiwari, got it or not? Going from here to there, from Prayagraj to here. Tiwari, अरे तिवारी आवाज सुनाओ जरा, अरे माइक ओपन करो भाई, बहुत दिनों बाद तुम एप्लीकेशन पे दिखे हो. माइक ऑन नहीं कर रहे हो? अरे यार, अरे हम लोग तुमको बहुत मिस किए यार. तिवरिया कैसे भूल गया पढ़ाई करना, नीट उट छोड़ रहा है, तैयारी वारी फिर से नहीं कर रहा अच्छे से, 10-10 घंटा पढ़ने के बजाय फिर से 2-3 घंटा पढ़ रहा है. सब तैयारी में लगे हुए हैं, समझे? 10 घंटा से कम पढ़ लिए, फिर से नहीं होगा, ये बात फिक्स है. तो नालो को हो रही है, 10 घंटा से कम पढ़े ना तो नहीं होने वाला है. स्प्रिंग फोर्स इज इन दी, हाँ तो वही तो मैं बोल रहा हूँ, नहीं पढ़ोगे तो काम कैसे चलेगा. तो इट इज 2mg/m. आंसर क्या हो जाएगा? दिस विल बी 2g मीटर पर सेकेंड स्क्वायर, and that is in which direction? Downwards direction. Which direction? Downwards. And this one will remain at rest. This is case 1. If I cut this spring, case 2. Case 2, when spring is made a cut. Okay, so let's take this example and means idea. Okay, so if I cut the spring, then what will happen? You can see that if I cut the spring, means then spring force immediately will become 0. This one immediately will change to how much? 0, because this is cut it. And you know that tension is not a like tension will immediately change after that. So what will happen is, I have a system like right now this way, that I have this, then this is there, and the block is attached to it. Okay, and this block is free to move. Okay, so look over here. Idea is that this is mass m, this is mass m. So upward spring force immediately becomes 0. Now, as soon as the immediately becomes 0, tension T immediately changes and it attains equilibrium state. T becomes equal to mg. This has weight how much? Mg. So it will have an acceleration in downward direction. Okay, because its weight is pulling it down. So this means it will do a motion under gravity, which we also call it as free fall. Acceleration will be exactly equal to how much? G meter per second square. Is that clear or not clear? Everyone, are you able to get me or not? Okay. So see, I can create any kind of such idea of cutting off springs, like joining two things together, joining three things together. You do one more example fast, and then I'll give you one tough question of cutting off springs, and then we'll move to the next topic. Okay. So let's take one more example. Example 3. Little bit be fast. Okay. If you solve it, then I'll not solve it, guys, online also. Heard or not? Okay. Block is there. Uh, Attached like this way. Okay. This is the spring of a spring constant K right now. Okay. Mass is M. This is again mass M. Same kind of question. Find the acceleration of blocks when we make a cut in. We make a cut in. Question number 1. First block. Sorry. In first scenario, in spring, and second question in row. Everyone, be fast a little bit. Just be fast. I'll bring my iPad. I have started recording. बालक यहीं हो? हेलो हेलो. आप हाँ, जल्दी 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 बनाओ थोड़ा सा. Done, guys?
हाँ
What is your answer?
जब स्प्रिंग कटेगी तब तो फ्री फॉल ही हो जाएंगे दोनों
Okay.
नीचे जाएंगे
हाँ हाँ.
स्प्रिंग कटेगी तो ऊपर वाला ब्लॉक जी से अपवर्ड डायरेक्शन में एक्सेलरेट करेगा और नीचे वाला वही जी से डाउनवर्ड डायरेक्शन.
Correct. Correct. Very good. Shruti? Same answer? ठीक है. ध्यान से देखो. So what is happening in this? The first part they say that what will happen if the spring is cutted. Okay. So case 1, when spring is cut. Okay, let me write first of all the FBDs. Okay. Weight how much? mg, tension T, tension T. This is again mg, and I have my spring force over here. So in equilibrium, T is equal to mg, and Fs is equal to T plus mg, which is nothing but 2 mg. So when spring is made cut, so what will happen? Your spring force, this implies spring force will immediately become 0. And when spring force will immediately become 0, what will happen? These all two things, since rope is not like any kind of rigid rod or something like that. So all of them will start to fall with an acceleration g. Okay, and therefore we'll write both blocks starts to fall with acceleration of gravity, and which makes the tension T to be equal to how much? 0. Is that clear now? In case 2, when a string is cutted or rope is cut, then this implies what becomes 0? Tension becomes 0. Okay. Sorry. Alright. So now look here. So now what happened? You cutted your string, so tension will become 0. If tension will become 0, but at that time, spring force will not become equal to 0, and it will not change immediately. You know that. And if it will not change immediately, that means that at that moment, mass M, let's suppose call this as block A, call this as block B. So acceleration of B will be exactly g meter per second square. But for acceleration of A, upward force is spring force minus mg divided by net mass moving. If spring force will be at that time 2 mg, so it is still mg by m, which is g meter per second square. So acceleration of A is upward and acceleration of B is downward in this scenario. Everyone, is this clear or not clear? Are you able to get me? यही आंसर आया था आदल? सुरुचि, यही आंसर था? Okay, so let us just as I told you, I'll ask you one. बेकार में ही क्या? कोई बात नहीं. कट
इक्वेशन ही नहीं आ रही थी. मुझे लगा हम स्प्रिंग काटेंगे तो स्प्रिंग को श्रिंक होने में भी टाइम लगेगा.
वही you don't have to think. No, you don't have to think like there will be time taken. Is that clear or not? Tension will react immediately, while the spring will react slowly. Is that clear or not? Are you able to get me or not? Okay. So, 1 minute. Let me write one last final good question and then I'll move ahead. Okay. Example, I think fourth this is. Okay. In this cutting of a spring scenario. Okay. With the wall, I have a heavy block. Okay. And I joined two springs over here. Okay. Mass of the system is m. It says that what will happen if I bring a cut in one of the springs? Is that clear or not? Okay. So question is saying two identical springs supports a mass m at rest. Okay. Find the acceleration of block just after cutting left spring. Okay. Ignore rotation. Be fast. Answer fast. मेरी आवाज आ रही है ना? आद्यन, सुरुचि, तिवारी, हेलो.
आ रही है, एक सेकंड.
Anyone? It's easy, man. Why you guys thinking it's
ये टाइम के साथ वेरी नहीं करेगा.
no no. रोटेशन एक
रेशन टाइम फील होता है तो
मैंने क्या बोल दिया? इग्नोर रोटेशन ना, इसलिए भारी नहीं करेगा. समझे? अच्छा, if I consider let us write the equations. So g by very good, correct Suruchi, awesome. Before cutting the springs, so before cutting the springs, let's suppose if I write the equations. So the weight of the block is there mg, and this is spring force, this is also spring force, correct? So if I write before cutting the springs, then the twice of a spring force is exactly equal to mg, and therefore a spring force is nothing but mg by 2. Reply me, yes or no? Clear? Now, what will happen if you cut the spring? So if I draw the FBD now, then after cutting the springs, what will happen? I will have only one spring attached. Okay. Chances of rotation are like very much likely over here, but we will ignore that. Okay. So weight is still mg and spring force is fs. But now the net holding force is went away, so downward force will become heavy, and therefore it will pull down with an acceleration how much? A. So what will be that acceleration? That acceleration will be pulling force mg minus of fs divided by नेट मास। आदम कौन सा कॉन्सेप्ट लगा रहे थे भाई? बहुत आसान क्वेश्चन है, सिर्फ तुम लोगों को दिमाग घुमाने के लिए दिया था।
नहीं उस पे नहीं, वो मैं उधर सोचने लग गया था।
हाँ
रोटेशन में तो ऑसिलेशन वाला था, मैं आने लग गया था।
हाँ नहीं,
मतलब वेरी करने लग गया था, ऑसिलेशन ऐसे नॉर्मल नहीं आता,
वो सोचना ही नहीं है ना। We are doing this in NLM. Okay, remember, whenever they write ignore rotation, or see if they will uh, be very simple that it's not the advanced that we will means the question will have all the ideas of rotation, oscillation or something like that. It's neat, correct? So they'll not ask you too much depth question. Is that clear or not clear? Be very clear about that. Okay.
तो वो वाला क्वेश्चन तो बहुत सही है। उसमें क्या कहते हैं, उसमें g cos थीटा अंडर रूट x अपॉन mt का रेशियो
आएगा।
तो वो टाइम पे फिर डिपेंड कर रहा है।
If that will be there, then वो इक्वेशन मानेंगे। हाँ,
अच्छा क्वेश्चन।
So now look over here. Let us take one more part of this. So till now we discussed maximum elongation in two ways: accelerating connected masses and static equilibrium. Then we considered this kind of all systems like vertically hanging system. Okay, little bit I'll go through the horizontally hanging system, and then we will just move to spring balances. Okay, case 2, horizontal attached bodies with spring. Horizontal attached bodies with spring. Is that clear or not clear? So let us take one idea. Let's suppose so case 1, example 1, I have 2 blocks. They're attached with the spring. And they are pulled by a force A. Okay. Mass is M. They are pulled by force F, and this is smooth. Okay. They are asking you find the maximum elongation in spring. Okay. Let us take it as M1, M1 and M2. Now, again, if you go through the concepts, we have done this kind of concept like maximum elongation scenario. And we told that whenever there is a maximum elongation, correct? Then maximum elongation will happen for you guys in two ways: static equilibrium and accelerating connected masses. So whenever net force is not zero, the acceleration will be there. And remember, over there in maximum elongation, what will not be present? Equilibrium will not be present. Reply me, yes or no? Just like this scenario, what was not present? Equilibrium was not present. But in another scenario, let's suppose if I just make like in these kind of cases, at maximum elongation, we have equilibrium over there. Is that clear or not clear? Everyone reply me, yes or no? So, over here, once again, if I write the value, let's suppose the whole system will be pulled with an acceleration A. This will be my spring force Fs. This will be again my spring force, how much? F of s. Is that clear or not clear? So, first of all, common acceleration, A common, it is F by net mass moving, which is m1 plus how much? m2. And then I want to find this spring force, so I can just simply write this for m2. For m2, only spring force is pulling it, so therefore spring force is equal to mass m2 into acceleration. Mass m2 into acceleration is what? m2f by m1 plus m. This is my spring force. Okay. Now if the spring constant is k, so therefore x max will be written as m2f by k times m1 plus m2. Is that clear or not clear? Reply me yes or no. And this is the scenario when it is a scenario when maximum elongation in the spring is happening. Now, I want to discuss this idea. One point I have taken. Whenever you saw that I am taking the word maximum elongation, then I'm fixing one thing, that both of them are moving with same acceleration. Both of them are moving with which acceleration? Same acceleration. Like over here also you can see that I have put it same acceleration. So you can keep this idea fixed, means whenever note, you can write like this, note that at maximum elongation during motion of the bodies, then both bodies will either move with, first point, same acceleration or same velocity. Same acceleration or what? Same velocity. Are you able to get me? Means you try to understand. See, let's suppose I'll take one scenario. Block of M is there. I attach one spring and I attach another. Now I started pulling this. You have started pulling this mass. Slowly you are pulling it. So till the time you are slowly pulling it, what will happen? The spring will stretch. Spring will stretch. The time till the spring is stretching, this mass remains at rest or not? Reply me yes or no. Correct. When the spring will be fully stretched, like the whole mass thing is there, the spring got stretched like this. Now furthermore expansion is not possible, then it will start to create an acceleration, and what you will observe, that whatever acceleration this is having, the same acceleration this will also have. So this is why I have written, when maximum elongation is happening, you have to always remember it happens at a point where I have which kind of acceleration? Same acceleration. Is this clear or not clear, my dear students? Reply me yes or no. Okay. It's not just for maximum elongation, even applied for maximum compression. Even it is applied for which kind of compression? Maximum compression. Okay, now, so this was one idea of horizontal path of maximum elongation. Second type of questions which is asked is this. Okay, like suddenly they will say that nowadays it will be very easier for you to understand. Oh, sorry, I have two blocks. Suchi, Tiwari, idhar hi ho? समझ में आया वो कॉन्सेप्ट?
नहीं, सो गया था।
सो गए थे?
नहीं नहीं, जाग रहा था।
तिवारी बोल रहा है कि भैया आज लड़ना है हमको। भाई प्लान व्लान है क्या लड़ने होने का? विचार में विचार कर गया हो क्या? मालूम हो रही?
आप कुछ भी नहीं बोल कि मैंने ईयरफोन्स लगाए नहीं है, अभी आप कुछ बोलेंगे। स्पीकर ऑन है।
ठीक है ठीक है। Let's suppose the force is there of 100 Newton. M1 is of 4 kg and M2 is of let's suppose 10 kg. Okay. Now, suddenly at random moment of time, okay, this mass M1 has an acceleration. Okay, the acceleration is given and its acceleration is 5 meter per second square. The time when acceleration of m1 is 5 meter per second square, they are asking you find at that moment of time calculate the acceleration of m2. Okay. Calculate the acceleration of mass m2 at this instant. Be fast.
एट
8. Everyone, is it 8 or what? Okay. So look over here. So this means that, see, what is the idea about this? That when this acceleration will be generated, it will try to bring a spring force over here, correct? Yes or no? Because see, when acceleration is there, it will have some spring force. It is trying to move it. So this spring force will be over here and this spring force will be over here. So now, I can measure the spring force due to mass m1 at that time, mass m1 into A, and it is 4 into 5. How much is that? 20 meter per second square. Is that clear or not? Now this spring force, if I put it for this one, then, so if I write it for m2 mass, then what will be that? 100 minus fs, and that will be equal to mass m2 into acceleration, which is 100 minus fs is how much? 20. Why I have written 20 meter per second square? 20 Newton it will be. Okay. So it's 20 Newton. So it is 100 minus 20 and m2 is 10 kg. So 10 into acceleration. Let's call it as a2. Is that clear or not? So yes, a2 is equal to how much meter per second square? 8 meter per second square. And 8 meter per second square along which direction? Direction of the higher force. Okay. Clear or not clear? Okay. Everyone? Yes or no? Balance? Okay. Let us write one more question based on this. Last. Let's suppose there is a block of 1 kg over here, and then there is a block of 2 kg over here. Is that clear or not? And 1 kg starts to move with an acceleration of, let's suppose, 3 meter per second square. There is no other force on 2 kg. Every surface is smooth. They are asking the question is, find the acceleration of mass 2 kg. Find the acceleration of mass 2 kg over here. Be fast.
And 1.5.
1.5. You guys got it? Proceed. This one, yes.
Okay.
This will be one spring force. This one will also generate one another spring force. Replying yes or no. This is spring force Fs. So now, the spring force which is generated is how much? Mass into acceleration, which is 1 into 3. So it is 3 newtons, correct? Now, 1 minute. I want to draw. Okay. So now, if I look for mass 2 kg, so for 2 kg, this spring force is only my accelerating force. So Fs is equal to 2 into acceleration. So this means it is A is equal to 3 by 2, which is how much? 1.5 meter per second square. Are you able to get me or not? Is that clear? Okay. Are you able to get me or not? One most important point in this concept is drawing the FBD of this, which is very, very important. Okay, so a little bit I'll take a small amount of time. How? Because see, in reality, you know that this 1 kg, if it is applied like this way, then the spring force is not taken like this. Correct? That's what I have taught you guys. But here I am taking like this. Correct? So let us just a little bit, we will draw the FBD of it. Is that clear or not clear? Okay. So that you can understand about this concept. So now look over here. If I take these masses, this is M1, this is M2. So this acceleration is generating some force over here at this point, correct? And at this point, this is trying to apply some force over here, and that force, let us call it as a spring force. For that, the spring will generate equal and opposite reaction, which is my spring force over here. Is this clear or not clear? Similarly, for 2 kg, if I try to draw, this spring force will be directed from this point like this way. And from this mass, it will be directed like this way. Is this clear or not? And this is how the FBD means, like acceleration of the bodies are preparing over here. Is this clear or not clear? Are you able to get me on? This is the real FBD of springs attached in horizontal or vertical cases. Horizontal or vertical cases. Is this clear or not? Are you able to get me, guys? Alright, no one is replying. Is this clear or not? Okay. Now let us bring last part of this spring force. Then we call it as spring balance. Okay. Now, first of all, what is spring balance? Anyone? Batao. What is spring balance?
मशीन होती है ना जिससे
हाँ.
वेट या कुछ
So,
करते हैं
well,
मूव करती है अपने आप
it's like a weighing machine. It is another type of weighing machine. Okay, it is another type of weighing machine. Okay, now how to give main major thing is now people just don't understand how did it is working. So it's like uh, a rectangular box will be there like this way, and it will be attached with a spring. Okay, over here some readings will be there, and over here there will be a hook with which you attach a different system. Is that clear or not clear? And when you attach it, based on the different weight, it reads the reading. But the question arises, how does it reads it? So let us understand one point. It measures, so spring balance, it measures the spring force present it measures the spring force present in the spring and how do we give the reading? What is the reading? Reading is given as, how does the reading is given as? First important point, it is written as T by, ना सुबह सुबह कौन पूजा करने लगा भाई? बगल वाली आंटियां कर रही है क्या अंशु पांडे? बगल वाली आंटियां पूजा कर रही है ना? गजब. सुना लो गोरी. So reading is given by T is equal to sorry what I was writing. My dear. So we'll write measured value is equal to force of the spring, okay, divided by gravity of that planet. Okay, this is also read in terms of tension by gravity of the planet. Is this clear or not clear? Are you able to get me or not, everyone? Balaks, yes or no? So let me just give you some questions based on this. 1 minute. One or two questions, and then we'll finish this particular spring balance. So we will be left out with only two more topics: pseudo forces and equilibrium, and friction, which we'll have to complete by tomorrow, today, tomorrow, or something like that, combined. Okay. Anyhow, my plan is that, so that we will not go any further more delay. By Monday onwards or Sunday onwards, we can start our work energy and power immediately. Okay. Now, reading is also this measured value has a SI unit. Okay. So always for students there is always a confusion that, sir, what does the word kg weight mean? So now it will be very clear. See, this measured value is written in terms of kg weight like this. Is that clear? What it is written as? Kg weight. So whenever in a question is written now, like a block 10 kg weight, right? Like this way it is written. Then you have to be cautious over there. 10 kg weight, it means what is given to us? It is given as force or means tension by gravity. So what I have to take it as mass over there? I have to take it as 10 into g over there. Reply me everyone, yes or no? Is this clear? Hello, Palak. Clear or not clear? So let us write one or two examples and then we'll move ahead. Okay. Okay. And over here there is a pulley. Okay. And it is attached with two different other masses. तिवारी यही हो ना? भाग गए तिवारी? अरे मैं सोचा कहीं चले गए। आजकल तिवारी और पाड़े लोग का तो बोलबाला है।
आप बोल रहे हैं, आप भी मिश्रा हैं, ज्यादा डिफरेंस नहीं होता।
Now look over here. Let's suppose I have a pulley attached with a spring balance, okay, and these blocks are 10 kg and 10 kg both, okay. Let us write like that. Both of them are first case 10 kg, okay. So question is saying find the reading of the spring balance. Be fast. Find the reading of the spring balance. Be fast. How much? 20. ऐसा यूनिट क्या लिखोगे? वही है kg weight, okay. So what is that answer? See, this means that how to find it. See, look over here. First, its weight 10g, 10g, tension T, tension T, tension T, tension T. So look over here. See, let me just have this before drawing all this. Let me one more diagram I'll have. Control C and over here Control V. Now let me do this. So now look over here. So if I place it, then if I mark all the things, then this is 10g, 10g, tension T, tension T, tension T, tension T. Acceleration will be how much? 0. So you know that net force on the pulley must be 0. So net force on the pulley must be 0. So it will apply a net force of how much? 2t over here or no? Is that clear? Everyone, yes or no? And the value of tension is how much? 10g. Correct? Sushi, here? Are you here or not? So therefore, what is the reading of spring balance? What it is written? Measured value is T by G of the planet. So here net tension is 2T. So measured value I'll write it as 2T by G, and its SI unit will be written as kg weight. So 2T means 20G by G kg weight. G cancel. It is how much? 20 kg. Wait, 20 ना? हाँ, आधे 20 बोले थे या 10 बोले थे?
20 में
Okay, clear or not clear? Take the same example. Okay. And write over here, instead of 10 kg, write 20 kg. Be fast, a little bit be fast. Now again same thing, find the reading of the spring balance. Answer? Again, this one means this one will read 2T or not? Tension in spring balance is 2T. Everyone, yes or no? बताओ तो कितना कितना
वैल्यू चेंज नहीं होनी चाहिए, नीचे का वेट तो बढ़ गया ना।
हाँ, so tension निकालो. So this time tension, since it will accelerate, so T will be equal to what formula? Twice or M1 M2 by G. What was the formula then? अरे आवाज M1 M2 G by M1 plus M2, correct?
आंसर आ रहा है मेरा
हाँ
800 by 3.
Let me check. M1 plus M2 is how much? 30. This is cancel. क्या क्या क्या? I think it is twice M1 M2 by G. Twice M1 M2 G by. So this is how much? 40 G by 3. Reply me everyone, yes or no? So therefore, measured value by the spring will be how much? 40 G by 3 into 2 divided by G in terms of kg weight. So this is how much? 80 by 3 kg. Clear or not? Tiwari, समझ में आया? Okay. Are you able to get me or not? Now, let us take last two more examples. Okay, which is important. Okay. Now look over here. See, first point. This is one scenario which is given. Okay, where two springs are connected. Okay. Okay. How many springs are connected? Two springs we are connecting to this masses, two spring balances are there. In one case it is connected in series, in another case it is connected in parallel. There is a reason why I have taken this example. Okay. Both are of same spring constant, and I am connecting over here 20 kg and over here also. Find the reading of each spring balance. Okay, call it as first, second. Similarly over here, first and second. Clear? So, see, in reality, this one, it's better to create one trick always. And whenever you create a trick, it is given by AI. AI means Anurag sir intelligence, got it or not? Okay. So AI says that first point, आ गया when springs,
सीरीज में
हाँ
100 न्यूटन है दोनों और पैरेलल में
10 10. So when springs are connected in series, then the reading of each spring, if there are identical spring balances, got it or not? Okay, then the reading of each spring balance will be same and equal to applied load, equal to applied load. Is that clear or not? When you connect them in series like this way, in first case, like case 1, is that clear or not? This will be the scenario. Case 2, when identical spring balance are connected in parallel, then again reading of each spring will be same reading, then reading of each spring balance will be same and given by, okay, formula is there. Okay, reading is equal to applied load by number of springs in parallel. Clear or not clear now? Number of springs in what? Parallel. Is this clear? Are you able to get me? This is the idea about this. In first case, it will be identical, exactly equal to applied load. So this means that spring balance 1 will also read 20 kg weight. Spring balance 2 will also read 20 kg weight. But over here 20 will be divided into two parts. So spring balance 1 will read 10 kg weight and spring balance 2 will read also 10 kg weight. Is this clear or not clear? Okay, everyone, is this clear or not? Now one last point is there. When, remember that when spring balance is connected where is connected in accelerating system, then it is also known by a name as known by a name as dynamometer. What it is called as, guys? Dynamometers. Is that clear or not clear? And over there, once again, we try to find. So we try to find, if someone asks you like find the reading of dynamometer in steady state. Okay, they will ask like this. So again, what it is, what it is, maximum elongation with acceleration. They are asking you a reading at maximum elongation with acceleration. Is that clear or not clear? Balaks, clear or not? With acceleration. Are you able to get me? Let's take one example. One tough one only I am taking. Okay. There are two blocks. Okay, masses are given 4 kg, 6 kg. And the forces are given. This is 4 newtons, sorry, 20 newton. And this is 10 newton. And I connect and dynamometer over here. Dynamometer means spring kind of balance. Okay, they are asking you the question as find the reading of dynamometer in steady state. So this is called as dynamometer. Okay, find the reading of dynamometer in steady state. Be fast. Immediately finish it, guys. बस और 5 मिनट, 5 मिनट से भी कम, 2 मिनट। ए सॉल्व करो जल्दी भाई, स्कूल जाना है मेरे को। हाँ हाँ, क्या बोला? 14। 14 रीडिंग लिखा हुआ है 14 बाई जी करेंगे ना
स्टेडी स्टेट है जब स्टेडी स्टेट ही है
हाँ हाँ
क्यों नहीं होता
स्टेडी स्टेट में
क्यों नहीं हो जाएगी स्टेडी
अरे स्टेडी स्टेट तुम पहले वाला लेक्चर देखो उसमें स्टेडी स्टेट समझाया हो now look over here so in steady state it is very clear that both of them because I have told it is at maximum elongation correct so maximum elongation means both of them will have same acceleration reply me yes or no so that acceleration will be because let's draw this is my spring force this will be also my spring force so common acceleration will be net pulling force which is 20 minus 10 by total mass moving. How much is that? 4 plus 6. So it is 10 by 10, 1 meter per second square. Take any one of the block and find the value of spring force. So if I write for 6 kg, it is 20 minus spring force is equal to 6 into acceleration. So this implies 20 minus spring force is how much? I have to calculate, sorry, is equal to 6 into 1. So spring force is exactly equal to how much Newton? 14 Newton. So if the options are given in Newton, you will write that reading of dynamometer is equal to either 14 Newton or 14 by G kg weight. Both are correct answers. Reply me everyone, yes or no? Is this clear? Saruchi, clear or not clear? So this was all about your spring ideas. All the spring cases I have done, everything is done. Maximum elongation, steady state and cutting of springs. Ultimately last also I completed dynamometer. Two more topics are left. Which are those two topics? Topics are your pseudo forces and equilibrium, which will be completing it tomorrow. Is that clear or not? Okay. Till that time, tada bye bye. See you.